This will be a video for 8th grade. We're going to do section 7.2. On this one, you're going to need a blank sheet of paper. We're going to solve 8 different problems. These ones are really not too much different than what we've done already. However, they look a little bit scarier at the start. We have, you see here on the first example here, we have fractions. We're going to also have some decimals as well. But I'm going to show you the trick where we can get rid of all of these fractions, we can get rid of decimals, and we won't even have to think about fractions after our very first step. So what we need to do here is we need to look at these denominators. Okay, we have a denominator of 5, 2, 10, and actually there's a 1 over here as well. And we need to find the least, lowest, what do we say, greatest, I'll just say least common multiple for a denominator. I know that 10, I'm looking at these numbers, and the answer is going to be 10, because 10 times 1 is 10, 2 times 5 is 10, 5 times 2 is 10, and 1 times 10 is 10. So we need to take these numbers, all 4 of these terms. We have a term right here, we have a term right here, here, and here. We take all of these terms and multiply them by 10 over 1 times 10 over 1 times 10 over 1 times 10 over 1. We're multiplying these. When you multiply fractions, we can reduce these fractions diagonally. It's the same thing as, we could have 70 tenths n, but we would need to reduce this fraction. And our whole goal is to get rid of fractions. So when we chose the number 10, that's going to actually get rid of all of these fractions, because 10 over 10 can simplify to 1 over 1. 10 over 2, we can divide those both by the number 2. It will be turned into 1 and 5. These 10 and 5, we can reduce by the number 5. We can divide by 5. So that's a 2 and that's a 1. And then there's nothing to reduce here. We have 1s on the bottom, so nothing to change. But I know 1 times 7 and 1 times 1, this is going to be 7n. Here I have 5 times 3, so plus 15, equals this. We only have 1s on the bottom. 2 times 3 is 6n. And we have 1s on the bottom. We have 2 times 10 is 20. So now we need to decide, are we going to subtract 7n from both sides or subtract 6n from both sides? I know it's easier to subtract 6n than it is to subtract 7n. So I'm going to do minus 6n minus 6n. And I'm going to end up with n plus 15 equals 20. And then, let's see. My next step on this problem is going to be n plus 15. So next step is going to be to subtract 15 from both sides. 15's disappear. I get n equals 20 minus 15 is 5. And we're actually done with this problem. Normally we would have another number right here that we'd need to divide by. But we don't have that number in this case because it's just a 1. So 1n is equal to 5. And that's our answer for the first example. For the next one, we're looking at our denominators. We have sevenths and we have wholes. So we're looking at the sevenths, and our lowest common one that we can make with these is going to be 7. So I'm going to multiply by 7 over 1. I'm going to multiply by 7. I'm going to multiply by 7 over 1. I'm going to multiply by 7. Those are all the numbers 7. I just didn't need a denominator on these wholes. So the 7s can reduce to 1 and 1. The 7s here can reduce to 1 and 1. So I have k minus 6 times 7 is 42 equals 3k plus 28. I can either subtract 3k or I can subtract 1k. It's going to be easier to subtract 1k. So minus k. I get negative 42 plus, negative 42 equals 2k plus 28. From both sides, I need to subtract 28. Can't divide by 2 yet. Could, but it's going to be easier for all of our problems if we just get in the habit of getting rid of this first, then dividing. Minus 28. Notice these are both negative signs. These are both minus, so this is going to be a very large minus negative number. So what I need to do is I actually need to add these together and just make sure it's negative. I get negative 70 equals 2k. And my last step is to divide by 2 on both sides to get rid of this 2. I get 70 divided by 2. Half of 70 is 35. Make sure it's negative, because half of negative 70 is negative 35. And that is equal to k. So k equals, or negative 35 equals k. All right, next example. So I'm going to find my papers. There we are. I've got 3/4 n minus 18 equals 1/4 n minus 4. So let's go ahead. Looking at my denominator, it's going to be a 4. If there's only one fraction, one size down there, fourths, then it's just going to be that number. So this is times 4 over 1, times 4 over 1, times 4, times 4. So I have 4's reduce, 4's reduce. I get 3n minus 18 times 4, 32. So this will be 4 plus 3, 72. Minus 72 equals, 4 is canceled, so n minus 16. I can subtract 3n or subtract 1n. I'm going to subtract 1n. 2n minus 72 equals negative 16. I need to add 72 to both sides. So this, I'm going to think like commutative property. I'm going to do 72 minus 16. This will have to regroup to a 12. From that 7 turns it into a 6. So I get 56. 72 is canceled. 2n equals 56. Final step, divide by 2, divide by 2. N equals, let's do a 56 divided by 2. 2's in 5. Well, how about this? Let's just do it a different way, because I know I can do 56. I can break this into 50 and into 6. Half of 50 is 25. Half of 6 is 3. So half of 56 is 28. Next one. Last one with fractions here. I have 6 plus 4/5 b equals 9/10 b. Looking at our denominator, we're going to need to multiply by 10, because I can make 10 with 5 and I can make 10 with 10. I don't have anything else on the right side of this problem, so it's going to be slightly easier than our last ones probably. So times 10 over 1 times 10 over 1. 10's reduced down to 1's. The 10 and the 5 don't go down to 1. It goes to 1 and 2 because we divided by 5. So I have also times 10, and there's nothing on this side. So 60 plus 2 times 4 is 8b equals 9b. So on this one, my first step is get the b's on the same side. So I'm going to subtract 8b from both sides. I get 60 equals 9 minus 8 is 1. 60 equals b. That was actually done. All right. So just to review those really quickly, we have, I'll just write, never mind. We just need to look at the denominator, and we need to multiply by the least common multiple of those denominators. And then you just reduce your fractions using your diagonals. So I'm going to move us on into, I've got 4 decimal problems here. We've got, the first one is 2.25k plus 5 equals 13.5k plus 14. And now we could solve as normal. We could just subtract and add with decimals, but I'm going to choose to get rid of decimals. And I'm going to show you what we're going to do. Like if I have the number 0.5 and I do times 10, well, that equals 5 because we move our decimal 1 time to the right. If I have the number 0.05 times 100, that's also going to be 5 because I move the decimal 2 times to the right. I see that I have hundredths place in this term right here. We go to the hundredths. So I'm going to take all of this problem and I'm going to go times 100. So 2.25k times 100 is 225k plus 5 times 100 is 500 plus 13.5, there's a 0, move my decimal 2 times, gives me 1,350k plus 14 times 100 is 1,400. So now we do have big numbers, but we got rid of our decimals. So easier to, I put plus here again, equals. Is it easier to subtract 225 or to subtract 1,350? Definitely minus 225k from both sides. Minus 225k. So I'm going to end up with 500 equals, the 0 turns into a 10, 5 turns into a 4. So that's 5. Put my k down there. 4 minus 2 is 2. 13 minus 2 is 11. Plus 1,400. Subtract this. Well, minus 1,400 minus 1,400. I get 0. Oh, well, let's talk about this real quick. This is negatives. So negative 1,400 plus 500. I like to think about that. Maybe I'm at 500 on a number line, and I need to go down by 1,400. So this was 500. So let's go down. 500 puts me at 0. And then I need to go down another 900. Takes me to negative 900. Or we could do 1,400 minus 500. And we're going to get 900. But make sure it's negative because the 1,400 was negative and it's bigger. So I have negative 900 equals 1,125k. And now in order to solve this, you're going to have to divide by 125, divide by 125. And this is something you could just type into a calculator. So let's do it, because I don't think we need to divide. 900 divided by 125, we get, and maybe you can see it, there it is, 0.8. So we get k equals negative 0.8. I have a lot of work on that one, but I think it's easier to get rid of the decimals at the start, and then at the very end, you just maybe type some division into your problem. The next one's not going to be a decimal as your final answer. The next two, 3 aren't going to have decimals. So the next one is 3.6w equals 1.6w plus 24. I have numbers in the tenths place. Tenths. It's just one spot after the decimal, so I only have to multiply everything by the number 10. So it's going to turn into 36w equals 16w plus 240, because everything's multiplied by 10. So subtract 16w, subtract 16w. I get 20w equals 240. Now I'm going to divide by 20. I'm going to divide by 20. W equals, well, these zeros can cancel off. 24 divided by 2 is 12. So that one's not so bad. Definitely easier than working with these decimals, though, I think. Next, negative 0.75p minus 2 equals 0.25p. I'm in the hundredths place here. So I've got to multiply everything by 100. So I'm going to do here, I'm going to have negative 75p minus 200 equals 25p. Got to move this over, so I'm going to add 75p to both sides. Add 75p. I have negative 200 equals 100p. Last step, divide by 100. divide by 100, cross your hundreds off. 200 divided by 100, p equals -2. Last one, 0.4x, I'll put 0.4x minus 5 equals 0.08x plus 3. I'm in the hundredths place here, so I'm going to have to multiply everything here by 100. So I've got, this moves over 2 times, so I have 40x minus 500 equals 8x plus 300. Subtract 40x or subtract 8x? Well, let's subtract 8x. Subtract 8x. 40 minus 8 is 32x minus 500 equals 300. Can't divide yet, so I got to add 500 to both sides. Add 500 to both sides. I get 32x equals 800. Final step, divide by 32. Divide by 32. You can do this on your calculator. X is going to equal, let's do it real quick. We got 800 divided by 32. 32 is an 8. That's no. 32 is an 80. It's going to be 2. That'll be 64. Subtract. That's a 10. 8 turns into a 7. So I have 1, 6, bring down a 0. I know that 32 times 5 is 160. So this will be 25. All right. So once we did our first step, we should recognize that all of the math that we did is the exact same as what we had in 7.1. We just have this first step where we need to get rid of the decimals, or this first step where we need to get rid of the fractions. So like, here's another example. If I have 1/2 x plus 1/2 x, how about minus 5 equals, plus 2/3 x equals 7/6 x plus 4. Well, let's look at our denominators. Can I make, I'm looking at 6. Can I make 3 a 6? I can. Can I make 2 a 6? I can. So I'm going to multiply everything by 6. You don't need to write this one down. I'm just pointing out this, the way we're solving this. This would be times 6. 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 This will be times 6. And we're just reducing diagonally to make this a 1 and this a 3. To make this is 30. This is a, divide them by 3, I get 1 and a 2. This is a 1 and a 1. So we'd end up with 3x minus 30 plus 4x equals 7x plus 24. And I think once we get to a step to like this, we wouldn't have any problems solving it. It's just that we're adding one step at the very beginning to get rid of those fractions, to get rid of those decimals. So with fractions, we just find the least common denominator, the least common multiple we can use for that denominator. And for decimals, you just find out how many times do we need to move that decimal to get rid of all of them, and you multiply by 10 or by 100. And that's all we added to this lesson. I did upload a material of Khan Academy videos, so if you're still struggling with these, there's some more examples of the guy on Khan Academy going through these types of problems. So there's some additional videos of those if you need them. Otherwise, just let me know if you have any questions. Post a photo of these 8 problems that we did, and that'll be your assignment for 7.2 for this week.